Course Introduction. This course is produced by the International Customer Service Training Department of Senfeng Laser and is the second lesson, Laser Cutting Process Training Series. This lesson mainly introduces the parameter setting interfaces for piercing and cutting processes, the definitions of related parameters, and the principles of the laser cutting process. It helps trainees understand how different parameters affect cutting performance and provides a foundation for subsequent parameter adjustment and process optimization. During the debugging process, in case of any unexpected situations, immediately stop using the machine and get in touch with the International Customer Service Department of Senfeng Laser to prevent accidents. Warning. Catalog. Chapter 1. Introduction to Cutting Parameters. Cut speed. The speed at which the laser cuts. The higher the speed, the less energy remains on the plate during cutting, resulting in a shallower cutting depth. The slower the speed, the more energy remains on the plate during cutting, which may lead to overburning. Nozzle height. The distance between the nozzle and the plate or tube during laser cutting. Gas type. Select the gas interface of the machine. Note that what is selected here is the gas interface, and the machine cannot automatically identify the type of gas connected. Compressed air and nitrogen should be connected to the nitrogen interface of the machine, and oxygen must be connected to the oxygen interface. Do not mix them. Gas pressure. The magnitude of the gas pressure used during the machine's cutting process. If the gas pressure of oxygen is too high, it will result in deep grooves on the cutting surface, increased roughness, and a wider cutting curve. If the gas pressure of oxygen, nitrogen, or air is too low, it will not be able to effectively blow away the molten slag, resulting in slag adhesion at the bottom. Peak power. The percentage of the power output of the laser during the machine's cutting process. The cutting depth gradually increases as the power increases. Actual power equals peak power times laser power. For example, for a 10 kilowatts laser, if the peak power is set at 80%, the actual power is 10 kilowatts times 80%, approximately 8,000 watts. Duty cycle. Set the duty cycle of the PWM modulation signal used during processing. When the duty cycle is set to 60%, a 8 kilowatts laser will be emitted for 60% of the time, and no laser will be emitted for 40% of the time. The laser's on-off state alternates. Pulse frec. The number of times the laser emits light within 1 second. The larger the value, the more continuous the light output. When the frequency is set to 5,000, it means that 5,000 laser emissions ranging from 8,000 watts to 0 watts occur within 1 second. Beam width. No need to change. Default is sufficient. Focal position. The vertical distance of the focal point relative to the upper surface of the plate. Zero focus means the focal point is exactly on the surface of the plate. When a positive number is input, the focal point moves upward. This is positive focus cutting, which is usually used for oxygen cutting carbon steel. However, it should be noted that if the focal point is too high, it may result in insufficient energy at the bottom, leading to incomplete cutting and slag backflow. Moreover, the nozzle is prone to overheating. When a negative number is input, the focal point will move into or below the plate. This is negative focus cutting, which is suitable for cutting stainless steel or aluminum plates with air or nitrogen. However, it should be noted that if the focal point is too low, the cutting gap is not conducive to slag discharge, and molten slag is likely to adhere. Laser on delay. The time during which the laser head remains stationary after the laser is turned on during cutting. Laser off delay. The time during which the laser continues to emit after the cutting head stops at the end of cutting a shape. The laser off delay can be set to a negative value. A negative value indicates the time between the laser turning off and the cutting head stopping. Chapter 2. Introduction to Piercing Parameters. Pierce mode. You can choose the piercing method, such as segmented piercing, nozzle step, etc. Pierce time. The duration of laser piercing during the piercing process. Piercing height. The distance between the nozzle and the surface of the sheet metal during piercing. The meanings of nozzle dis, gas type, gas pressure, peak power, actual power, duty cycle, and pulse frequency are the same as those in cutting parameters. Beam width. No need to change. Default is sufficient. Focus pass. The position of the focal point relative to the tip of the cutting head nozzle. A negative focal point must be used during piercing. End PT focus. This parameter is used when the lightning piercing mode is employed. For gradual piercing and segment piercing, this parameter can be set to 0. Pierce time. When segmented piercing is selected, it refers to the time for piercing. Gas blow. After the current stage of piercing is completed, it is the time period for only blowing gas without emitting laser light. This is used to blow away the molten slag from piercing and cool the material. Gas type. The gas used for the current stage of piercing. Note, the piercing gas should be consistent with the gas in the cutting parameters. Pressure. The air pressure of the gas used for the current stage of piercing. If you have any questions or require further assistance after watching this video tutorial, please contact our after-sales service department. Thank you for watching.